Section 6.1, Part 1, Slope Fields. So a slope field is a graph showing short line segments representing slopes of a function at lattice points in a plane. The slopes are given by an equation for dy dx. So to create a slope field, we have a differential equation in terms of dy dx. In this case, we have dy dx equals the quantity y minus 1 squared cosine pi x. And we want to create a slope field for this differential equation. So the way that we're going to do that, if we look at our empty graph at the moment, we have various points already labeled on our graph. So we have 0, 0, 0, 1, 1, 0, 1, 1, so on and so forth. So we have 9 points on our graph. To create a slope field, we are going to plug in the x and y values at each one of these points to figure out what dy dx is equal to. That will give us a slope, which we will then use to create tick marks on our graph. So for example, if we look at the point -1, -1, so this point over here in the corner, if we plug in -1 for x and -1 for y, we'll get that dy dx is equal to -1 minus 1 squared cosine -pi. Right? And when we do that, we'll get 4 times -1, which is -4. So the slope at -1, -1 is going to be -4. So because it's negative, our slope is going to go down, so our tick mark is going to be a negative slope. And -4 is a pretty steep slope, so we're going to do our best to make the line as steep as possible without being vertical, because our slope is not undefined, it's just -4. But it's a very steep negative slope. Okay, so if we look at 0, 0, we'll have dy dx is equal to 0 minus 1 squared cosine of 0. So we'll get 1 times 1, which is 1. So at 0, 0, our slope is 1. So we're going to make a tick mark that's positive and has a slope of 1. Right? If I were to continue this line, it would go straight through this point. So this line would have a slope of 1. So my tick mark has a slope of 1. And we'll continue this process. If we look at -1, 1, so this one right here, we get 1 minus 1 squared cosine -pi, which is equal to 0 times -1, which is just 0. So a slope of 0 at -1, 1, 0 slope is a horizontal line. Right? So if we continue this process, we'll see that at -1, 0, our slope is -1. Then we have 0, then 4, then 1, then 0, then -4, -1, and 0. So every time we have a 0 slope, so at 0, 1, and at 1, 1, our tick lines are going to be horizontal lines. And every time we have a positive 1 slope, our tick line with a positive slope with a slope of 1. And then negative slopes, -1 slopes, so at -1, 0, and at 1, 0, our tick lines will be negative slopes and then we have negative 4, 4, and negative 4. So our positive 4 will be a steep upward line. Our negative 4 will be another steep downward line. And that's how we create our slope field. So by plugging in x and y, we can identify the slopes of those lines and create our tick marks. So on the next page, we are given two slope fields. So for number 2, we have a slope field for the differential equation y over 8 times the quantity 6 minus y. And we want to sketch possible solution curves through the points 3, 2 and 0, 8. So these points have already been identified for us, and we want to sketch possible solution curves. So let's start with 3, 2. So 3, 2 is right here. To sketch a possible solution curve for 3, 2, what I'm going to do is I'm going to follow the curve of these tick marks, right? So I'm going to follow it on the right side, seem to be curving, 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 and then kind of mellowing out. And then on the left side, we're curving downwards and sort of mellowing out when we get to the x-axis. And for 0, 8, up in this corner, the right side seems to be curving, and the left side seems to be just going upwards. So we've sketched possible solution curves using the tick marks on our slope fields to guide our lines. Now for number 3, we're given a slope field and asked to identify which differential equation could possibly be which equation could possibly be a solution to this curve. So by looking at this curve, we can cancel out some of these possible solutions already. Right? A sine curve, we know a sine curve looks something like that. Right? This graph does not seem to be doing that. If we pick a random point and draw a possible solution curve, this graph is not going to go up and down in the way that the sine curve does. It also does not seem to mimic a cosine curve. So A and B we can cancel out immediately. X squared, if we sketch a graph of x squared, we have a parabola, right? Both ends of my graph are going either upwards or downwards if it was negative x squared. This slope field has one end of my graph going upwards, one end of my graph going downwards, so it can't be C. So we're down to ln x and 1/6 x cubed. So to sketch 1/6 x cubed, I can just look at the x cubed. Right? We know that an x cubed graph, a cubic function, has a shape similar to this. And ln x has a shape similar to this. If I were to compare either one of these two graphs to my possible solution that I drew on the slope field, it most likely resembles D. Right? A cubic function where one end is going downwards, one end is going upwards, and there are no limitations on its ability to cross over the y-axis. So if you continue on, we're only going to do a couple of these together, and we're not going to fill out the whole entire thing. But we're going to do a couple of these so that we can see if we can find some sort of pattern. Okay, so if you look at 1 and 4, 1 and 4 are differential equations that only have the variable x. Okay, so y is not going to affect the slope fields that we create. And because of that, this means that for every x, so for every horizontal section of my slope field, my tick marks are going to look exactly the same. So when I do x plus 1, if x is 0, if x is 0, then my slope is 1. Right? All along the y-axis, x is 0. So my slope is going to continuously be 1. When x is negative 1, my slope is 0, which is a horizontal line. So all along negative 1, my slope is 0. When x is negative 2, my slope is negative 1. So all along negative 2, I will have a slope of negative 1. And as I continue outwards, my slopes will get steeper, either positively steeper or negatively steeper. Right? So if I go to 1, if x is 1, 1 plus 1 is 2, so I have a slope of 2. So I'm just making my tick marks just a tad bit steeper every time. And that would continue on. Similarly for number 4, when x is 0, our slope is 0. So all along the y-axis, I'll have a slope of 0, and so on and so forth. Now if we look at number 2 and number 5, those differential equations are all in terms of y. So because they're all in terms of y, x is not going to affect the slope that we sketch with the tick marks. So when y is 0, our slope is going to be, in this case, when y is 0, our slope is 0. So we'll have horizontal lines all along the x-axis because y is 0 along the x-axis. When y is 1, our slope is 2, so we'll have a slope of 2 all along the horizontal line when y is 1. When y is negative 1, we have a slope of negative 2. So everywhere that y is negative 1, I'm going to draw a slope of negative 2. And so on and so forth. And similarly, if you look at number 5, when y is 0, our slope is negative 1. So all along the x-axis, we're going to have a slope of negative 1 because y is 0 all along the x-axis. When y is 1, we have a slope of 0, so we'll have horizontal tick marks all along the line where y equals 1. When y is 2, our slope is 1, so we'll have positive 1 slope all along when y is 2, and so on and so forth. So for 3 and for 6, we're taking into account both x and y. So this is very similar to page 1 where we had to plug in the point, the x and the y value, to figure out what the slope would be at that point and go forth from there. The last page of notes is a matching activity that you can do on your own, and if you would like me to check it for you afterwards, I will do that in class. But that is the end of 6.1.